Hi, welcome you all. Today I am going to discuss about the topic on modified electrode for sensors. When the electrodes are used for sensing application, during that case some chemical reaction occurs. Oxidized products are accumulated on the surface of electrode. Once when the oxidized product accumulate on the electrode surface, the electrode loses its reusability, selectivity and limits its application. This is called as electrode poisoning. To overcome this problem, the electrodes are modified chemically, that is, by adding a suitable conductive substrate on the electrode surface. When the conductive substrate is coated on the electrode surface in the form of thin layer coating or thin layer or self-assembled monolayer. Once when the electrodes are modified with conductive substrate, it enhances the electron transfer kinetics. The modified electrode possesses new physical properties, chemical properties, optical properties, electrical property, optoelectrical property and electrochemical properties. These properties are modified. They are shown excellent activity in these properties. That's why modifying the electrode by using chemical substance not only protect the electrode, it also enhance the applications of electrode in various areas. When the chemical substance are coated on the electrode surface, this can be done by four methods. They are adsorption, process, covalent bonding, polymer film coating, and next one is composites. These are the four different methods available for the conductive substrate to coat on the electrode surface. Adsorption. Adsorption is a surface phenomenon. The molecules are adsorbed on the surface of another molecules. Adsorption can be into two types. One is physisorption, that is physical adsorption. Another one is chemisorption. This chemisorption is a irreversible process, and physisorption is a reversible process. When the electrode surface are coated with a conductive substrate, so imagine this as a conductive substrate, this as a electrode surface. This conductive substrate coat on the electrode surface by chemisorption process. The conductive substrate chemically adsorbed on the electrode surface. This happens by satisfying the valence of the atoms present on the surface. If the valence are already filled, the conductive substrate are torn apart. That's why we are telling this chemical substance chemically adsorbed on the electrode surface, which is nothing but a chemisorption. It is an irreversible phenomena. Once adsorbed, it won't turn apart. But if adsorption should happen means the surface atom should consist of a valence electron, vacant valence electron. The valence electron should be available to adsorb the species or substance on the surface of electrode. If the valence are completely satisfied, then the incoming conductive substrate torn apart from the electrode surface. This is one method. Another one is covalent bonding. The electrode surface is coated with a conductive substrate. This conductive substrate, so imagine that this as a conductive substrate and this as a electrode surface. The conductive substrate forms a covalent bond with the electrode surface. The conductive substrate forms a covalent bond with the electrode surface. For this purpose, we are using organic silanes and cyanuric chloride. So, we are using chemical agents like organosilanes and cyanuric chloride. And next method to modify the electrode surface by means of coating the electrode surface with polymer. When polymer is coated on the electrode surface, it is coated in the form of thin film. How it is possible? So, polymer is coated on the electrode surface, which involve three methods. The first one is through chemisorption process. Chemisorption process. And next one is the polymer film is coated on electrode surface by low solubility in contact solution. Low solubility in contact solution. This polymer is coated on electrode surface by physical anchoring with porous electrode surface. Physical anchoring in porous electrode. Before coating the polymer film, this chemical species present on the surface is removed from the self-assembled monolayer, and then the polymer is coated on the surface. Polymers used for coating shall be either organic, inorganic, organometallic. These polymers were used or coated on the electrode surface. Next one is composite. By the composite method, we can coat the conductive substrate on the electrode surface. Here, the chemical modifier is mixed with electrode matrix material. The chemical modifier is mixed with electrode matrix material. For example, an electron transfer mediator is mixed with carbon paste electrode. An electron transfer mediator is mixed with carbon paste electrode. And what type of electrodes were preferred? So, three types of electrodes were used. They are carbon paste electrode, glassy carbon paste electrode, glassy carbon electrodes were used. Among these three electrodes, glassy carbon electrode is mostly used. Why? because this glassy carbon electrode need low background current and it is chemically stable. Low background current is chemically stable. And mostly we prefer carbon based electrodes because of its low cost, biocompatibility, good electron transfer kinetics. So far we have discussed about the four methods involved in coating the conductive substrate on electrode surface. Now we will see what are the materials used for coating the electrode surface. Various materials were available. Now we will shortly discuss about the carbon nanotubes, that is graphene. Next one is polymers. Graphene. The structure of graphene is shown here. Graphene is a 2D nanomaterial, that is two-dimensional nanomaterial. The carbon atom present in graphene undergo sp2 hybridization. It possesses large electrical conductivity, high surface area, high tensile strength, low cost. Due to these versatile properties, graphenes were employed along with electrode surface for sensing chemical substance. For instance, graphene is fabricated with graphite electrode and it is used for the detection of ascorbic acid, uric acid, dopamine. Not only this chemical substance, graphene was fabricated at the bare graphite electrode for sensing various chemical substances. For instance, I have notified only 3. Why graphene is preferred to fabricate? Because graphene possesses added advantages like it possesses high electrical conductivity, large surface area, good tensile strength, low cost and biocompatibility. Graphene can be reduced thermally. Graphenes are thermally reduced, that is, it can be reduced in number of ways. One of them is thermally reduced, hydrothermally reduced, partially reduced, electrochemically reduced, multi-nanopore graphenes are also prepared by reduction. These are the number of ways that a graphene can be reduced. Graphene is a single sheet which on folding it forms carbon nanotube. When a graphite sheet is folded, imagine this as a graphite sheet. When this graphite sheet is folded, that is when it is binded together, It is called as single wall carbon nanotube. When multi-layers of graphene were folded or binded together, it forms multi-wall carbon nanotubes. These carbon nanotubes also possess added advantages like high electrical conductivity, good tensile strength, toughness, flexibility, semiconducting property, metallic property, electrical property, etc. The detailed information of carbon nanotubes will be discussed in forthcoming topics. Next one is polymer based modified electrodes. The electrodes are modified by using different types of polymer. They are coordinating polymer, electroactive polymer, ionic polymer, biological polymer. This electroactive polymer contain groups which can be either oxidized or reduced. Based on this, it provides sensing chemical action. The polyelectrolyte polymers consist of ionic groups. Electroactive polymers, polyelectrolyte biopolymers. This electroactive polymer consists of groups which can be either oxidized or reduced. By this oxidation or reduction reaction, the electrode senses the chemical substance present in the given sample. The polyelectrolyte consists of ionic groups. It attracts opposite charges present in the solution. When polyelectrolyte is coated on electrode surface, the ionic group present in the polymer attract opposite charges present in the solution to the electrode surface. So biopolymers means it involves usage of polymers like enzymes, DNA, antibodies. These polymers were used in biosensors. Next we will see the methods available for a polymer to coat on electrode surface. A polymer is coated on electrode surface by two types of method. One is dip coating, another one electropolymerization. Dip coating. Dip coating means when an electrode is dipped into the polymer solution, the polymer is coated on the electrode surface. Later, the solvent is evaporated. This polymer is coated on electrode surface by the action of chemisorption and covalent bonding. In the case of electropolymerization, the electrode is reacted with monomer. On electropolymerization, the polymer is coated on the electrode surface. When the electrode with monomer on electropolymerization, it forms a thin film or thin coating on the electrode surface. The thickness of this thin film depends on the concentration of monomer and applied voltage. Once when polymer is coated as a thin film, we can dope ions for specific applications. The method is more specific as it no need to evaporate the solvent present on the electrode surface. When the electrode is coated with the conductive polymer, it undergoes three types of reactions. That is, it involves three types of steps: rate of charge transfer, rate of mass transfer, nature of chemical reaction. If the rate of charge transfer and the nature of chemical reaction exceeds the mass transfer, then the reaction involves diffusion controlled. If the charge transfer is low, charge transfer is low and the polymer is not good conductor, in such case it won't allow the analyte. The reaction lies underlying the electrode. Many polymers were used to coat the electrode surface. Specifically, polypyrrole is preferred. Why polypyrrole? Because it possesses good redox activity, water solubility, biocompatibility, enhanced conductivity, ease in the modification of electrode, strong absorption of analyte. Due to these special properties, polypyrrole chosen as the best polymer for coating on the electrode surface. On comparing polymers and metals, polymer possess advantages. They possess electronic properties similar to metal. Interference of ions are avoided. It prevents electrode poisoning. Biocompatible. Even though it is advantageous than metal, it also possesses a few advantages. These polymers undergo swelling, oxidation, mechanical weakness, instability. These properties limit the use of polymers in diverse applications. It limits the polymer to employ in diverse applications. It possesses limited applications, that's all. And today we have discussed what is the need to modify the electrodes chemically for sensing action, what are the methods available, 4 methods: adsorption, covalent bonding, polymer coating, composites. What are the chemical substances used for coating the electrode surface? We have discussed graphene, carbon nanotube, polymers. That's all for today. Thank you.